A quantum computer is an advanced computer that uses the principles of quantum mechanics to perform calculations at speeds unattainable by even the top supercomputers of the modern world. To understand how a quantum computer works, imagine that you're playing a game of chess and want to predict all the possible moves your opponent might make. You can do this with a classical or regular computer. It will go through each move of your opponent one at a time until it runs through all possible moves. This process, as you can imagine, can be time-consuming. However, if you had a quantum computer, it would simulate all possible moves of your opponent at once, in a fraction of the time the classical computer took. This is similar to what a quantum computer can do in the realm of analysis and computation. A quantum computer and a classical computer are similar in some ways. Both have circuits, chips, and logic gates to process information, and they are both operated by algorithms. However, the primary difference lies in how they process information. Classical computers use binary bits, zeros and ones, representing the on or off state of a current. Quantum computers, on the other hand, use qubits, which can exist in both states simultaneously, a property known as superposition. This unique ability of qubits opens up a world of possibilities, allowing quantum computers to process information in a fundamentally different way than binary bits, and potentially revolutionize the future of technology. Let's consider the concept of superposition using an everyday example. When you flip a coin, it can show either heads or tails. But when the coin is spinning in the air, what state would you say the coin is in? Is it heads or is it tails? While it's spinning in the air, it could be argued that it's both heads and tails, correct? Similarly, a qubit can exist in both the 0 and 1 states simultaneously. In a quantum computer, a system of multiple qubits can simultaneously possess multiple states, allowing the quantum computer to process many solutions simultaneously, something a classical computer simply cannot do. This capability enables quantum computers to solve problems much faster than classical computers. The magic of quantum computers doesn't end with qubits and their multiple states. These multiple states of multiple qubits can be linked to each other, or in the language of quantum mechanics, they are entangled with each other. Entangled qubits work in a way that the operations of one qubit can influence other qubits, no matter how far apart they are, and can also influence the entire system. This allows for significantly higher computational power, something that classical computers cannot achieve. Entangled qubits function seamlessly due to a phenomenon called quantum entanglement. We have already made a dedicated video on quantum entanglement, and the link is in the description. Additionally, a quantum computer looks nothing like your regular computer or laptop. When you walk into a room housing a quantum computer, what you'll most likely notice first is large, complex-looking machinery, much like a chandelier, with golden, silver, and blue parts. Around it is a maze of wires, tubes, and other intricate components. The setup looks straight out of a sci-fi movie. Quantum computers have been in existence in various forms for several years. In fact, some tech companies already possess operational quantum computers that serve as valuable resources for software development and programming languages. The most significant advancement in quantum computing in recent years occurred in October of 2019, when Google asserted that it had achieved quantum supremacy with its quantum computer. This entailed using their specialized Sycamore processor to perform a specific type of computation much faster and more efficiently than the most powerful classical supercomputer. This demonstration of quantum supremacy validated the concept that quantum computers can indeed surpass classical computers in specific tasks by leaps and bounds, and can execute operations that classical computers cannot. This progress also prompted other companies, such as Microsoft, IBM, and several startups, to intensify their quantum research in pursuit of even greater results. Once the full potential of quantum computers is realized, it will herald a world of truly unimaginable possibilities. Quantum computers have immense computational capabilities that will greatly enhance artificial intelligence. Quantum cloud computing services have the potential to revolutionize machine learning by processing extensive amounts of data and complex calculations at unprecedented speeds. In cybersecurity, quantum computers could uphold data encryption during active use, providing robust protection. They are also poised to revolutionize medical and drug research, weather forecasting, and automobile battery technology. While it will take many years before quantum computers become mainstream and see large-scale commercial use, it doesn't seem like an exaggeration to say that quantum computers will eventually be powerful enough to not only solve complex problems, but also help you find your missing socks, predict the outcome of your next dinner date, and maybe even explain why you walked into the kitchen